Okay, Form 4 student, let's see force 3. Okay, 4 forces are acting on the object as shown below. So what is the magnitude of the resultant force? So let's see. First of all, we consider the vertical component. So the upward force is actually equals to 30 Newton and the downward force is equals to downward 10 Newton. Okay, so if you want to find out the net force on this direction, it should be 30 minus 10. So it is 20 Newton. And then when you consider the horizontal component, it should be towards the right. And the magnitude of it should be 40 Newton minus 20 Newton. And also it is 20 Newton. Then you would have a resultant force in both directions 20 Newton as shown. One is to the right and one is upward. Both of them are 20 Newton. When you want to find out the resultant force, that would be this one. It would be 20 square plus 20 square, taking the square root of it. The answer would be 28.3 Newton. So the answer is A. And then it said that in question 2, an object is handed at rest by two strings as shown in the figure. If the tension of both strings are 30 Newton, find the weight of the object. Both of them have the tension here and then you have the weight here. Now consider you have the vertical component and the horizontal component. Both of them, the net force is 0. So to the upward equals to the downward, and to the left is equals to the right. The force that is pointing upward would be 2t times sine 70 degree equals to the weight. And the force to the left is actually the t cosine 70 degree. Now let's see, the t is this direction and then it have two components. One is vertical, one is horizontal, and the angle is here. So this one is t sine theta and this one is t cosine theta, like this. Both of them are similar. Okay, so equals to t cosine 70 degree. Okay, so when you want to find out the weight here, you can use the tension, import it to it. So 2 times 30 times sine 70 degree. Weight would be equals to 56.4 Newton. So the answer is D. And then for a luggage of mass is 18 kg is pulled by a force as shown below. If it is accelerating at 1.5 meter per second square to the right, find the force, assuming the friction is negligible. So friction is equal to 0. You can see that because it is accelerating to the right, so the net force is in this direction, equals to ma. And this is provided by the force to the right, and you can see that the force is this one. You can resolve the component, one as the vertical, this is F sine theta and F cosine theta. And the horizontal one is providing the acceleration of the object. So this is cosine 60 degree equals to 18 times 1.5. So 18 times 1.5 divided by cosine 60 degrees. F is equals to 54 Newton. So the answer is D. So let's see in the short questions. Draw the free body diagram of block A. Now be careful that some of you are not precise for the free body diagram. Some of you draw something like this. Okay, now be careful that the weight has to be vertically downward from the center of the object. And the normal force should be perpendicular to the contact surface. And the force that is pulling it upward, actually the name of it is tension. Some of you only named it as F. Remember, if you are not using the common symbol for those forces, you have to write down the full name of the forces. And some of you put affections there. Now, you can see that it is indicated by the word smooth. So which means that the friction is 0 here. Okay, be careful that to read the question carefully. Words mean something, okay? Oh, both spring balance show a readings of 2 Newton. Find the net force acting on A. Now, the readings of it are, I think it's good that most of you know about it. So readings is actually showing you the tension is equals to 2 Newton. Find the net force acting on A. The net force should be in this direction, which is equals to tension minus weight sine theta, which you can see that if you're using this direction, the tension of course is pulling it upward along the plane, but the weight is actually this one can be resolved into two components. One is this direction and one is this direction. And this one is the force pulling it downward along the plane. Okay? Downward along the plane. You can use that 2 minus the weight of mass is 0.5 times 9.81 times sine 20 degree equals to 0.322 Newton. Okay. The acceleration of A measured by the motion sensor is 0.641 meter per second square. Does this experimental data agree with Newton's second law? Explain briefly. Now this one is actually quite complex. You can see that by the force that we can calculate is acceleration. So F equals to ma. The force is 0.322 times equals to the mass that is 0.5. The theoretical value of the acceleration is actually 0.645 meter per second square. Now you can see that some of you say that this does not agree, but you can see it is still close to the experimental value. It is a little bit larger than the experimental value, because you can see that sometimes there are some measurement error or even frictions that it existed in the real world. So this is still agree with the Newton's second law. Okay. Now, and then for part D, it said that using the experimental data, but some of you use this one instead of the experimental data. You should use the green one, because it said that you have to use the experimental data. So if you use 0.645, you will not be given any marks because you did not follow the instruction. Okay? So estimates the mass. You can consider the B, that is the weight of B. This is the tension. The net force is downward now. So weight B minus T equals to mB times A. This is mBg minus 2 equals to mB times 0.641. Two equals to MB G minus 0.641. MB equals to (0.218 kilogram). Okay. Complex because it says that you have to use experimental data, but just be careful. It is not difficult. It is complex but not difficult. Thank you.